Hi, I'm Dan. Today I'd love to show you how we design solar PV systems here at Terra Energy Solutions. Let's take a look.
The first thing we need to look at is energy usage. At survey we will ask you for your annual energy consumption in kilowatt hours. This can be found printed on your energy bill. For this customer, we will input 5,000 kilowatt hours per year. We will also ask you about your usage patterns. Most households fall into an evening peak. Finally, we'll look at your current energy tariff and then work out what would be the best proposed rate. Once the energy tab is complete, we move on to the fun stuff, the designing. Here you can see the customer's home. It's the second house on the left. Lots of tabs here, we'll go through them one by one. Firstly, we'll place the panels. We need to select the panels that we're currently working with. For us, at this moment in time, that would be the Longi 430 watts. We'll select them here. I can then add panels. I have an option for portrait or landscape. Here we will try portrait. We place one, and then we go along as so. So 10 panels here definitely fits. It looks like we can get 12, but 14 might be a stretch. Satellite's a good estimator of design, but it's not perfect. In this case, we've already surveyed this customer's home and we are confident that we can fit 14 panels. So we will add 2 more here. We do try and offer only the amount of panels that we can definitely fit on a roof to avoid disappointment on the day. If we hadn't attended site already, we may well make this 12 panels until the point where we had conducted the in-person survey. And that's the panels. Next stage, we select the mounting. For us, that's fasten sole. Inverters. We have 2 choices for inverters, and this really depends on whether you're having a PV only system or a PV and battery. Let's look at solar PV only first. We have 6 kilowatts of DC power from the panels. This means that our peak production would be 6.02 kilowatts. For string inverters, let's look at the Solax range. We have a 5 kilowatt Solax, which is very common, but actually we do have access to a 6 kilowatt in this case, which matches up very nicely with our DC generation. So let's select this one. We can also decide how to string this system. 14 panels is probably on the limit of a single string. So in this case, we will do 2 strings, one of the top row and one of the bottom row. So here we would have 6.02 kilowatts of DC power and an inverter that can produce up to 6 kilowatts of AC power. If this wasn't a solar PV only and it was a solar and battery, let's start again and see how that would look. For solar PV and battery, we have 2 choices. We can either keep the solar PV inverter, string inverter only, and add a battery and inverter, or more commonly, we can use a hybrid inverter. We're slightly more limited on the power range for the hybrid inverters. So in this case, we would use a 5 kilowatt give energy inverter. Let's select that here. Stringing can stay the same. I would still recommend 2 strings, 1 for each row of panels. This customer does in fact want a solar PV and battery system, so let's leave this 5 kilowatt hybrid in place and go. We always recommend we supply the same manufacturer of batteries and inverters, so we would be looking at the Give Energy battery range here. The main batteries for this inverter would be the 5.2 kilowatt hour or the 9.5 kilowatt hour. This customer selected the 9.5 kilowatt hour, so we'll select this here. As it is hybrid inverter, this battery will be DC connected. We have a few battery control scheme options. The first and most basic is self-consumption. This will store excess solar and deliver it to the house when required. There is a few more options here. They're quite detailed, so I won't go into them now, but we will briefly cover maximize savings, as this is probably the option we will select for you. Using maximize savings, we will build in not only the solar PV charging, but also overnight charging. In the UK, there are plenty of tariffs available that offer a cheap overnight rate. If we jump to the Energy tab quickly, you can see that our proposed rate is Octopus Go. Octopus Go will give you, I believe, 4 hours cheap overnight rate charging. Currently around 7.5 pence per kilowatt hour. Let's click into this quickly and we can see that we have included this. So here we have 2 rates. That is actually a little high. That's the default. Let's change that to the current rate as of June 2024, which I believe is 0.245 pence. And we have a nighttime rate of 7.5 pence. What this means, I cut there I think. We can go into a fair amount of detail with the charging schemes. If you need more information, we can discuss at survey, or you can contact us at phone and email. So let's move on. I do need to set a price for this, so let's just set an arbitrary price of, let's say, £10,000. So, the online proposal. This is the page that you will see as a customer when we present the design. Everything you've seen up to now is our side of things, but I thought it would be great for you to see how we do what we do. So this will be your proposal. You can see here we have 14 panels and a battery. If there was multiple designs, they would appear here as different tabs that we could cycle between, but for this example we've just used one. So we can see we have a 6.02 kilowatt system size, £10,000 system price. Now this is estimating that we're going to save £1,277 per year. When we scroll down, we'll see where this comes from. So we can see a visual of the panels. We can see the suggested products. Here's your hybrid inverter, here's your 9.5 kilowatt hour battery, and then it does add in all of the equipment that we need. Not all of this is correct. You can see there's optimizers from when I click the add optimizer button. We wouldn't actually use the Solar Edge, we would use Tigos. So don't pay too much attention to what you can see here other than the panels and the inverter and battery. Going down, we can see our system performance. This is one of my favorite graphics. So the blue bars are your generation in kilowatt hours per day. As you can see, May, June, July, the summer months have the most generation. We look at January and December and we get the least. The grey area behind this is your total energy consumption. You will use slightly more energy in the winter. This is mainly because we have a lot of heating appliances in the UK and we have not a lot of cooling devices in the UK, although this is changing. Below this we have environmental benefits. We have a graphic of how your system works under different use cases, generating excess solar, partially offsetting usage, or nighttime. Here's what most people consider one of the most important parts. We have an old bill versus new bill on a monthly basis, and we have lifetime bill savings for 1 year, 5 year, 10, 15, 20 years. We do expect these systems to last around 25 years, so we could also have added a 25 here, but 20 is a good estimate. Here you can see the rates we input from earlier, 24 pence for the daytime, 7 pence for the night time. In this particular example, we've used no SEG, so no export tariff. These are readily available now. As of June 2024, you can easily get 15 pence per kilowatt hour export, so we could actually have added that into the energy column. And finally, we can see our payback time. So for this system, it's going to cost us £10,000. It's going to save us £51,848 over its 20-year life. So you can see that it takes 6 years and 6 months to pay itself back. The £10,000 is a very arbitrary amount. That's not what it would truly cost to us at all. But it's 6 years payback is probably what we see a lot. We can see as low as 4 or 5 years. We can even see 2 or 3 years for commercial. We can also obviously see higher payback times, 9, 10 years, if say we're not on a south-facing roof, if it's the cost of install is increased for any reason, like we're working with slate tiles, or it's very high scaffolding cost. There's a multitude of factors that go into the final price. but we do see between 5 to 7 years payback on average. So that's it really, that's how we would design a solar PV system for you. We have skimmed over a lot, we've missed some things. I didn't want to include absolutely everything because the video would be too long and no one would get to the end of it. So congratulations for getting to the end of it. If you are interested in installing solar PV with us, we'd love to hear from you. If you are watching this on the website, just click the contact us at the top of the page, submit your details and we'll get back to you straight away. If you're watching this elsewhere, check the comments section below. We will list email to contact us, website details, phone number and everything. However you get in touch, we'd love to hear from you. Hope this has been of help and thanks for your time.